Assalamu alaikum, students. Welcome to my channel, Cambridge Companion. And today we will do question number three of the paper Cambridge AS and A level, May June 2023, variant 22. So, where we start the question number three. Figure 3.1 describe a sequence of the reactions that can be used to produce a food additive compound Y from CH3Cl2. Okay, there is the reaction. You see the step one, where X is step two, and this is the uh, propanoic acid, and the step three with the calcium, and there is Y. State the regions and condition for the step one. Okay, here is the step one. Uh, you see here the step one. Here's the step one. Okay, so there's a nitrile group instead of the chlorine. Okay, so I just want a zoom for the better, you know, okay, better view. Okay, so state the region and condition for the step one. Okay, so there's CN. It means it's condition KCN or potassium cyanide is the ideal in ethanol. KCN in ethanol is the and plus heat, um, plus heat. So we have done. Okay, now move to the uh, next part. Part 2, give the symmetric name of the X. What is the symmetric name of the X? Here's the X. Okay, you can see CH3, CH2, Cn is the X. Okay, so we have the three carbons. We all know 3 means prop, and there's a nitrile group, so it's propane nitrile. Okay, it's propane nitrile. It's propane nitrile, yes. Propane nitrile. This is the answer. So this is the answer, propane nitrile. Identify the type of the reaction that occurs when dilute acid is added to the X in the step 2. Okay, this is the step 2. So what type of the reaction is this? So this is I think you see that the dilute acid and it's become the carboxylate acid is here this side instead of the nitrile group. So this is hydrolysis, acid hydrolysis, you can say. Yes. Acid to bracket, right, acid hydrolysis. I think acid hydrolysis is the answer. Okay, so we have done with this. Now question number 4. Question number 4, sorry, not question number 4, question number 3, uh, part A and the part 4. In step 3, Y and a gas are produced. In step 3, Y and a gas are produced. Construct an equation. You see here, this is the step 3 and here's Y. So just writing the equation what we will, here's the equation. You see that this is with calcium, okay? So CH3, CH2 and carboxylic acid, okay? It's propanoic acid CH3, CH2, uh, COOH, which is a carboxylic acid, or you can say the compound are propanoic acid, okay, plus calcium. So what we will get? CH3, CH2, COO, Ca, because calcium is along with this compound, not H, and hydrogen is a gas which is produced, and hydrogen gas. Okay, so this is the compound what you know, uh, but this is the product we will get. But please make sure that the equation is balanced. So first it is put the bracket around here. I think there's something wrong. It's not really the same problem with the previous video. Just okay. Uh, I think the CA and there's a bracket and what is 2, and so the equation I think is not balanced because 3 to the 6 carbons. So here if we put 2, I think it is balanced now. Okay, so move to the next part, B. The B is a part which is propanoic acid can be also formed from propanol or propanol and potassium trichromate 6. Okay, state the conditions needed. So what will be the conditions? So conditions is acidic conditions and heat under reflux. Acidic conditions I think it's, acidic conditions, yes. Acidic conditions plus heat. Yeah, yes, and heat. Okay. Now, this is the last part of question number three. Yes. So complete the table 3.1 to show the number of the sigma bonds and the pi bonds present in the molecule of the X. Okay. Uh, Molecule of the X. How many sigma bonds and how many pi bonds are there in the molecule of X? X, here the X, which is propane nitrile. So I think we should draw so we can uh, so accurately how many sigma and how many pi bonds are present there. CH3 CH2, yes, CH3 CH2 CN. It will be like this is the formula, structural formula. CH3 CH2 CH2 and what is propane nitrile, yes, and CN. We all know that C makes a triple bond with N. So here's the structure of the propane nitrile. So sigma bonds, what means it's a single bonds. Pi means double bonds. So how many sigma means single bonds and how many pi bonds mean double bonds are there in the molecule. So sigma bonds there we can count it's 1, 2, 3, 4, 5, 6, 6, and there's a pi bond which is double bond. Here's the two pi bonds. This is the two pi bonds. Okay, pi bonds mean double bonds. And again with left with uh, this bond you can calculate. It means there are only two pi bonds are present in the molecule, means double bond. Here's the two, and left with 1, 2, 3, 4, 5, 6, 7, and 8. So we have 8 sigma bonds here in the molecule. So this is a question number 3 we have done. So I hope you'll like the video, students, and please like my video and subscribe my channel Cambridge Companion. uh, we will do the question number 4 in the next video. So thanks for watching, and please like my video and subscribe my channel. Thank you.